To understand a histogram, we first need to get into the idea of bins. So what we have here is a graph that represents Lake Travis water levels. These are taken from January of each year from 1980 to 2016. So the first question says there's one observation in the bin centered at 620. So that means we're talking about this bin right here. And we can see from the fact that these centers are spaced apart by 10 units each, that means each bin width is also 10, which means this goes from 615 up to 625. And we see that there's one observation, which we can tell from reading over to the vertical axis here, that the height of that bar is 1. So there's 1 year in this range during which the water level of Lake Travis was between 615 and 625 feet. To figure out in what year that occurred, we need to look at our list of data. We have water levels by year. We can't tell the year from the histogram at all. So looking through our list, we can see that there's one data value between 615 and 625, and that year was 2015. Now, Lake Travis is considered full when it's at 680 feet, but let's just for simplicity say if it's above 675, we're going to consider it full. The reason I'm choosing 675 is that it is a break point here, and that way we don't have to try to estimate half a bar, right? So here's 675. Everything that's above 675 is going to be in bins to the right of 675. So we're looking at this bar height here, which is everything between 675 and 685, and this bar here, which is between 685 and 695. So let's estimate those bar heights. Looks like 15 for this one, and looks like 2 for this other one. So that gives us 15 in the tall bar plus 2 more in the short bar, which is 17 years total in this date range that the lake would be considered full. Now we can also look at our data and find those values. This is going to take a little bit longer, so I'll just pause and highlight them all. So we can now count up those 17 values circled over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So we can see how it is that this histogram represents this list of quantitative data, where the quantitative data is really just one variable here, the Lake Travis water levels. We're not also including the years in this graph. So we might also be interested in the question in what percent of the years was the lake full. We know that it was full in 17 years. Now we just need to figure out how many years total are included in our range. This goes from 1980 to 2016. So the first thing we might think to do is subtract, which gets us 36. But since we're including both endpoints, both 1980 and 2016, we need to add 1 to that difference because we're basically starting from a 0 instead of starting from a 1. So we have 37 years total in this date range. So we would just bring in a calculator to find this proportion. 17 divided by 37 gets us 0.459. And to convert that to a percent, we will move the decimal point 2 places to the right. So a little bit less than half the time over this date range, the lake has been full. Now, there's not just one way to define bins for a histogram. We certainly can make each bin a little more narrow or each bin a bit wider. And what you see happening is that if you have lots of bins like we have in this first example, it's hard to see any real smoothing of the shape, and it tends to do a lot of jumping up and down. Often we want enough bins to see whatever smoothing is possible. So this might be too many just because it's not very smooth. Whereas over here we have, this is a reasonable histogram still, but maybe we prefer to have more bins because we could see, for example, in that last histogram that there were a few empty bins over here as we get into the lower levels. So that in fact what we had was some drought years and some non-drought, heavy rain years, and that there wasn't a lot of in between. So maybe that's something that the histogram with more bins helped us to see, but this is still an okay graph too. In StatKey, we'll find that the histograms start out using 10 bins, and that's often a really good number of bins for getting the amount of smoothing that we want. But we can change the number of bins by moving a little slider, as we'll see when we get into our StatKey tutorial. In general, I would say the number of bins we want is enough to get some smoothing, but not so much that we lose all of the detail.